That's done.
You don't need it.
You should not need equations of planes. We have seen that a line is determined by a point and a direction vector. You remember? R is equal to A plus lambda B. You need to know a point and a direction vector.
B is your lambda.
Lambda is your parameter.
Oh, sorry.
B is your direction.
Vector. A is the point.
Point. Since a plane is two-dimensional, it is determined by a point and two non-parallel vectors. So you need a point, you need one point, and you need two sort of direction vectors, non-parallel vectors. Okay. So that means you need a point. This is the node point, and B and C are your direction vectors.
Does that mean two skewed vectors, or what does two non-parallel vectors mean?
When they're not parallel to each other.
So they intersect somewhere.
Yeah, they intersect somewhere. They intersect somewhere. Yeah, they're not skewed.
Okay.
Because you can't draw a plane passing to two skewed lines. If you have two lines like this,
you intersect somewhere because your
planes has to pass through both those direction vectors also. So it's like this. If you want to just picture it out, you have
I draw it here.
Yeah, plane. This is like you need two direction vectors and you need a point.
Okay.
So this is a position vector of a point, correct? This B is your direction vector 1. C is your direction vector 2.
So what is a plane? Is it like a
plane? Like a paper. The
iPad
is a plane. The laptop screen is a plane.
But we're saying that these two vectors are flat on it, or they have
flat on it.
They're flat on it.
Flat on it.
Okay. It's not like this.
No, it's not rotating. It's not rotating. It's flat.
Okay.
Lambda and mu are independent parameters. A is a position vector of a point, correct? A is a position vector for known point, and R is a position vector for a point R on the plane.
Okay.
So your R is always the x, y, z. It's like a variable.
Yeah.
Variable point. Okay. Now see, find a vector equation of a plane containing A, B, and C. Now this is a vector equation. So this is called that. There are 3 forms of this: normal form and vector form. This is vector equation of a plane. That's what we do.
What does that mean?
Vector equation of a plane is we are writing in this form. R is equal to A plus lambda B plus mu C.
Okay.
Is there your formula booklet? So it's called vector equation of a plane. So if you open your formula booklet, they have written vector equation and they have written that. Yeah. Vector equation of a plane. So that's the form. What is A?
A is your any point.
Position vector of any point on the plane.
Yeah.
What is B?
B is the direction vector.
One direction vector. What is C? Another direction vector on the same plane.
Okay.
That's what I'm showing you. There are two direction vectors.
So B is for one of these vectors, C is the other one.
That's C is the other way.
Okay, got it. But A can be any point.
A can be any point regardless. B also is any vector in that plane. Okay. C is also any vector in that plane.
Understood.
But B and C should have the same plane.
So but these 3 points that they're given us A, B and C.
No, A, B and C are not 3 points.
No, that's not answering the question.
Question is having A, B, C.
So those are coordinates or those are
coordinates? No? Round matrix is coordinates.
Okay.
So how will you do that? So your requirement is you need 1 point.
And we need 2 vectors.
2 vectors.
So I find AB as one vector, BC as one vector.
Perfect. That's
and I can take like A as a point.
Game over. So your point, so you need your position vector. So point OA I take 1, 2, 3. Correct? Then as you correctly said, I can find vector AB. See, there are a number of options. You can find out AB, AC.
Yeah.
You can find out BA, BC. You can find out CA, CB. Find any 2 vectors.
Any 2 vectors you can use.
Yeah, any 2 vectors here. Yeah. So this is B minus A. So B minus A. So that is 3 minus 1, 1. Then you have your vector BC. Correct? The BC, you can take any, you want to find BC or what?
Yeah, so BC.
BC, chalo. It is one matter. This is a point. And this is your direction vector 1. Correct? This is your direction vector 2. So BC is C minus B. So C minus B. Minus 2, 4, minus 5. Correct?
Yeah.
So therefore what will your vector equation be? R is equal to?
Let's take point A as a...
Yeah, that we have taken. So minus 1. Why does this happen? I don't know. You should not. Minus 1, 2, 3. plus, what is it? Lambda times the first vector
times AB.
plus mu times, that's it. That's your answer. What is this called?
The plane vector equation.
Yeah, vector equation of a plane. End of the story. Okay. However, another form is more commonly used. Now, this is not commonly used. The other form is more commonly used.
Okay.
Okay. For one thing, just think of how many ways you have done question 1. It will not be easy to tell that these vectors represent the same plane. Obviously, somebody will do AB,
Yeah.
somebody will do CA, C.
Yeah, but
So you won't come to know. Somebody, instead of point A, you can also use point B. So it's very difficult to see. Correct? In 3D space, it's also determined by a point and a normal. So this is how it's mostly done.
What does that mean, sir?
You have a point, you need to have a known point. Here the diagram is shown. You need to have a known point and you need to have a normal. Normal is perpendicular to the plane. If the plane is perpendicular to the plane.
So you're using the vectors of flat curves and not flat.
The normal is perpendicular to the plane.
Normal is perpendicular. Okay.
So D1 and D2 are the direction vectors on the plane. That is a different story. That's method 1.
Okay.
Other method is this now maybe.
Okay.
So suppose you want to find an equation of a plane that passes through points A.
Here which is determined by a point and non normal vectors. So does the point have to be on the plane or can it be anywhere?
Point on the plane.
Point has to be on the plane. Okay.
Point has to be on the plane. So for a line also the point has to be on the line.
Okay.
For this the known point has to be on the
plane. It can't be in the air.
Yeah, correct. It can't be in the air. It has to be. That's a good question. Suppose we want to find the equation of a plane that passes through point A, x1, y1, z1, x1, y1, z1, and as a normal vector this, as shown in the diagram. So there's a normal vector.
Okay.
So you have a point and a normal vector. Then he's given some explanation. I'll tell you what formula you use. This is your formula. What is the formula? R dot n
is equal to A dot n.
Is equal to A dot n. That's your normal form. Equation of a plane using the normal vector. R dot n is equal to A dot n. This is very, very important. So always when they ask you to find a vector equation of a plane, always use this.
R dot n. Okay, so this is the main one that we use.
This is the main one.
A,
that is just when you go for a music concert, how you have starters who start the show.
Just like that.
It's like that. They start the show. The main boss is here.
Okay.
R dot n is equal to A dot n.
Okay.
So all that is inspired by.
Slope gradient form.
Yeah, it's like that.
Okay.
Now this is simple. Direct. Find equation of a plane with normal vector this and containing points this.
Okay.
So what will you do? What's the formula?
R dot n is equal to A dot n.
So R dot, what's your n? 1, 2, 3. A, what's your A? A is a position vector. It's a position vector. Remember, it's a vector.
Okay.
It's not a coordinate. So minus 1, 2, 3. Minus
so
1, 2, 4.
Round brackets. Doesn't it mean it's a
dot 1, 2, 3.
Doesn't round brackets mean it's a distinct coordinate?
No, coordinates.
But then so I saying it's a position vector.
Right? You do this minus O. This minus the origin, no?
Oh, they're basically the same thing.
The same thing. Because your origin is 0, 0, 0. That's what I'm trying to tell you. For position vector, for position vector of point, the coordinates become the direction, become the vector itself. Position vector.
They see the same thing.
Same thing, yeah. Now you know how to find a dot product, no?
Yeah.
R dot 1, 2, 3 is equal to minus 1 plus 4 plus 4 3s are 12. So that's how much? 15. Correct?
Yeah.
What is this called? This is a normal form.
Okay.
Second form, this is a normal form.
Got it.
Now, can you figure out how to find a normal vector if you've been given two vectors in a plane? Actually, if they ask you to find a Cartesian equation of a plane, so there are three forms. There is a third form.
Okay.
Cartesian equation. So Cartesian equation when you're finding, let me do for this one. Let's find a Cartesian form for this one. You know how to find a Cartesian form?
No, sir.
It's very simple. What's your R?
My R is
XYZ.
Okay, XYZ. Okay.
So put XYZ and get the dot product. So to convert a normal form to Cartesian form is very simple. You simply replace your r by xyz. You replace your r by xyz dot this is your normal vector 1 2 3 is equal to 15.
Okay, so x plus 2y plus 3z is equal to
X plus 2y plus 3z is equal to 15. That's your Cartesian equation. Simple.
easy.
So to get to the Cartesian equation, you have to go through the normal form.
Good. Okay.
So normal form is the main deciding factor. When you're doing any long questions, just think of this: r dot n is equal to a dot n. That's it.
Okay.
So you have to get the normal vector, and you have to know the point.
Understood.
End of the story. There's like slope point. So you have normal and point.
Got it.
But just remember that point and normal.
Okay.
Look at the formula and just meet the requirements and substitute.
And your
End
r
of
you
the
always take as just x y z, any random x y z.
That's a variable. Equation should have x, y, z.
Yeah.
When
Okay,
you use y, when you use y is mx plus c, you're
You have
trying to
to
find
have
a value
x
of
and
m and c.
Yeah.
X and y, you leave it as x and y for an equation.
So that's your r over there.
That's your r basically
Got it.
in terms of vectors. So you draw those parallels, then you'll remember. Will you try this out?
Yeah, let's see.
Find a Cartesian equation of a plane containing points a, b, and c.
Okay.
There are 3 points in a plane. So you have a plane. And these are the 3 points. So you have a plane and these are your 3 points A, B, C. Now what are the 2 requirements here? You need a point, which we have. Sure. So point is you can use your point OA.
You need 2 vectors. You find a, b, or b, c. Or
Correct. We found A, B, and B, C. You can refer back and tell me what was A, B was.
So AB was 3, -1, 1.
3, -1, 1.
And BC was -2, 4, -5.
We found it earlier, so you can do obviously B minus A.
Yeah.
And you can do C minus B and get this. Now, so what are we getting is, we are getting vector AB. Look at, now we are getting vector AB. And we are getting vector BC. We are getting these 2 vectors. How will you get a normal now? You want a normal, you want something which is perpendicular to the plane.
Correct.
90 degrees to the plane. And
does it necessarily have to be a point B? Okay.
It can be anywhere.
A or C.
It can be anywhere. It doesn't matter.
Okay. So
you have to do the cross product. You remember? Right hand thumb rule.
over here, how would that work?
So you'll do AB cross BC. So your normal vector will be the cross product of any 2 vectors in the plane. Any 2 non-parallel vectors in the plane.
Your cross product is your normal.
Yeah.
Of any 2.
That's what I told you. If you have one vector, you have another vector, your cross product always gives you the 3rd vector which is perpendicular to both these vectors.
Okay.
So when you do cross product.
How does the right hand rule work in this?
So right hand rule is, suppose you do A cross B, na? So your right hand, you turn it from A to B. So this is my A cross B.
Wait, so what do you do there?
Right hand thumb rule, na? You take your fingers curling from A to B.
Oh, okay. So it goes up.
It goes
so
up.
Going from
B to A will be down. So AB is equal to minus BA. So A cross B, because A cross B will look up, will direct up, and this will be directed down.
That makes sense.
So right hand thumb rule. You remember how to find this?
What, sir? Cross
Cross
product?
product?
Yeah, I do it.
So do it like so. So your AB, so you put in your IJK, and your AB is 3 minus 1, 1. Your BC is -2, 4, -5. So the first one is your AD minus BC.
But that should be following.
Correct. So if you want to do AD, that's 5 minus 4. Correct. The second one, so you have to remember always this is plus minus plus. Huh?
Okay.
Minus J. Now J, if you're doing, means you'll do this minus this. Huh? So 5 3s are negative 15 plus 2. Correct? Plus K times 4 3s are 12 minus 2. So that will be I plus 13j, correct, plus 10k.
I plus 13j plus 10k.
Correct.
Hmm.
So my normal vector is 1, 13, 10.
Okay.
Correct. If you write in the column form, column vector you write like this, is equivalent. Always work in column form in IB.
Okay.
And generally they give you column form. Generally,
Okay.
yeah?
And now I have to
Now,
go back to the equation.
That's it. Game
So
over.
R is dot.
So R dot n is equal to A dot n.
Again, any point.
Yeah, R dot n is equal to A dot n. So R is your x, y, z. Dot n is 1, 13, 10. Is equal to A dot n. A is minus 1, 2, 3. Dot 1, 13, 10. So that's x plus 13y plus 10z is equal to minus 1 plus 13 2s are 26
55.
plus 1 plus 30. Yeah, 55. So x plus 13y
Plus 10
plus 10z 10z is equal to 55. That's your answer.
Not too bad.
Distance between a point to a plane. That is
Okay.
line to a plane. Now distance between a point and a plane.
So this means the point somewhere in space.
Point is somewhere in space. Not the point is not on the plane.
Okay.
So if you have a plane somewhere in space,
Does it help to think of this vision?
yeah, this is a point.
Again,
Correct?
the entire unit.
Yeah. This you're looking at this distance, the perpendicular distance.
Okay.
Obviously, you look at the perpendicular distance. So, find the coordinates of the foot of the normal. So, this is the foot of the normal. From A is 2 minus 1, 3, and this is the plane. Achha, by the way, in IB they call plane as what you know?
What, sir?
Capital pi.
What?
Capital pi. So plane pi.
So in economics we call that profit, over here they call it plane.
Yeah. so you'll find pi 1, pi 2. So the planes. Capital pi.
Pi 1? How you can have more
Pi
than
1, pi 1, plane 1, then you have plane 2.
So you can have more than one plane?
Yeah,
In
you'll
one
have
plane?
intersection of planes. Yeah, it's coming. Don't worry. Intersection of planes.
What if we just don't struggle?
So so now see, this we are looking at point and plane. Then there'll be line and plane.
Line we did.
Line and plane.
Mm-hmm.
Intersection of line and a plane. Then there'll be intersection of a plane and a plane.
I don't want to get there yet. So
Yeah, we'll get there.
I'm gonna get very confused.
Now, how do you do this?
What are we trying to find? Okay, so
You're finding the foot of the
you
problem.
have to find
You
the
have to
foot
find the
first.
coordinates of P.
Hmm.
You have to find the coordinates of P so that this is there.
So from this equation, can we convert it to? Can we find the two vectors? Like the two, can we find the two vectors on the plane using this equation that they've given us?
How?
The reverse of what we did earlier. So from this Cartesian form, first we convert it to the normal form.
Okay. Now,
Then you convert it.
now tell me, if I give you the equation, the Cartesian equation of the plane, can you tell me the normal vector?
Yeah.
What is it?
I'll just do. No, I can't.
Look at your formula booklet. You think backwards. In this sum, suppose if I give you this equation, from this can you get the normal?
Yeah, technically yes.
How?
So because whatever
It's 1, 13,
30 and
10.
10 go stacked up like that.
Correct.
X, Y, and Z.
Correct. So that means the normal vector over here would be what? Normal to the plane would be what?
1 minus 1, 2.
Correct. 1 minus 1, 2. Okay.
So this,
that's the normal
line
to
is 1 minus 1.
that line. That vector A, like vector PA
Is 1 minus
1 minus 1, 2. Now, if you assume, Acha, can you find a, let me do it this way. Can you find a equation of line PA AP?
Yeah.
Equation of how?
So now I know that now I know there is 1 minus 1 2, right? So then
What is
can,
1 minus 1 2?
the
What is the direction vector of the line?
I don't know. I will need to find.
Direction vector of the line is what? The normal will become the direction vector of the line. See, this normal vector is like this, correct? That's along the line, na?
Yeah. So it becomes the direction vector.
So the normal becomes the direction vector of the line.
Okay. Okay.
Now what will you do? So what will the vector equation of the line be? Therefore, equation of AP.
So A plus lambda B.
R is equal to A plus lambda B. Correct? R is equal to, what's your A?
A can be
2 minus 1 3. That's the only possibility. There's nothing else. Plus lambda B is your direction vector. 1 minus 1 2. Correct? Now, if I call this x, y, z is equal to 2 minus 2 plus lambda minus 1 minus lambda 3 plus 2 lambda.
Yeah.
So let point P be 2 plus lambda minus 1 minus lambda 3 plus 2 lambda. Because point P is a common point, no? It lies on the line as well as it lies on the plane.
Yeah, both. Right.
So now I am taking it lies on the line. Now this lies on the plane also, lies on plane as well.
Yeah.
If it lies on plane as well, you can substitute this. You can substitute x, y, z by the coordinates of P. So 2 plus lambda minus 1 minus lambda plus 2 times 3 plus 2 lambda. I'm putting x, y, z in the plane.
Correct. So you're putting these points.
Yeah, x, y, z I'm putting in the plane because it lies on the line. And solve for lambda. So that will be 2 plus lambda plus 1 plus lambda plus 3 to the 6 plus 4 lambda is equal to 27. So that's 4, 5, 6 lambda is equal to 27 minus 8. Correct? 6, 8, 9. Sorry, 9. 6 lambda is equal to 18. So lambda is 3. Correct?
Yeah.
So, what are the coordinates of point P therefore?
I just plug it into.
Yeah.
So this becomes.
So you put this in this. Correct? That's your 5 minus 4. Correct? 9. 3 2 is 6, 7, 8, 9.
Yeah.
That's the foot of the perpendicular. And the shortest distance?
We could just be distance formula now.
Distance formula, or you can use find vector AP and find the magnitude. Anything is fine.
So root of x.
Yeah, you can both. You find vector AP and find its magnitude. I do vectors by, so that you remember, okay, AP is OP minus OA and all that,
Yeah.
Therefore, you can also use distance formula, but I'm trying to just remind you of vectors every time. Minus OA, 2 plus 1 minus 3. So that's 3 minus 3 and 6. Correct? Therefore, the distance is your AP, root of 9, 6 6 are 36, root of 54. 9 6 are 54.
It's fine to make it third, no?
That's fine. Important, huh? Again, very, very important. There are a lot of steps that came in actually.
Yeah.
So let me repeat what happened. The coefficients became the normal vector. First, you found the equation of the line. The normal vector became the direction vector of the line. So you know your point and you know the direction vector. Correct? So R is equal to A plus lambda B. Substitute that. Correct? You will get your x, y, z. Now this x, y, z lies on the these are the coordinates of P. That lies on the line. Correct? Your lambda is equal to 3. Put this back in this. You get the coordinates of P. Find a vector AP, find its magnitude, and that is the distance. So the shortest, this distance is 3 root 6. We got the coordinates of the foot of the perpendicular also.
Understood.
Okay.
Yes, sir.
This is what we need to learn. So if you have a country and you're dropping a bomb, perpendicular distance, shortest distance, you just drop it. So this, so far you have done correctly. So what you did is you recognize that this is your vector equation of the plane, correct? That means this is your point. So that's your 1 0 3. 1 0 3 is your point. This is your direction vector d1, correct? This is your direction vector d2. Now to get the normal, what did you do? You did the cross product. So you do your ijk 4 minus 1 1 2 1 minus 2. So that is equal to I
plus 10j.
That this is how much is it? 2 minus 1 minus j minus 8
minus 2
minus
plus
2 plus k.
4 plus 2.
So I did it how we did last time. Huh? So if people are viewing the thing, if they don't understand, they should look back. 10j plus 6k.
8k. Oh, that's why we got this.
Correct? Now, so therefore, that becomes the normal to the plane. Therefore, normal vector is 1, 10, 6. This will become the direction vector of the line. Suppose if I call this M, direction vector of line PM. The normal will become the direction vector.
Yeah.
So direction vector line PM will become 1, 10, 6. Correct? Now what do you do?
R is equal to A plus lambda.
Now R is equal to A plus lambda B. So your A plus lambda B. So R is equal to A is my known point.
15 to
Any point on the line. Correct. Minus 6, 15 to perfect.
1
Plus lambda times
1,
1, 10, 6. Nice healthy equation it is. So therefore your X is equal to minus 6 plus lambda. Y is equal to, because you assume your XYZ from that. Because your R is your XYZ.
Y is equal to 15 plus 10 lambda and G is equal to 2 plus 6 lambda.
2 plus 6 lambda. Correct? Now what do you do with this? This, where does this XYZ lie? This is lying on the line.
Yeah.
But this is the coordinates of M. It should also lie on the plane.
Yeah.
So you substitute this in the plane. What is the equation of the plane? Oh, acha. That is where it will be useful. What do you found? You can put it here also if you want to.
But that I erased.
That would be useful if you can do that. Yeah, you can. That would be easier to do.
Yeah, because then you just put it everywhere.
Yeah, you X, Y, Z, you put that. So now, so this is your M ka coordinates is minus 6 plus lambda, 15 plus 10 lambda, correct? And 2 plus 6 lambda. Now let's find the equation of the plane in Cartesian form.
Okay, that's what I've done.
Yeah, that's what you have done correctly. So R dot N, which we require, R is equal to A dot N. So R is your X, Y, Z. Normal vector is 1, 10, 6. A is any known point on the plane now. So that's your point A on the plane is 1, 0, 3. Correct? And therefore your point on the plane is A. And N is your 1, 10, 6. So that means the equation of this is X plus 10Y plus 6Z is equal to 1 plus 0 into 10 is 0, 18. So X plus 10Y plus 6Z is equal to 90. Now you substitute the point. This point lies on the plane. So you substitute that. Minus 6 plus lambda, 10 into 15 plus 10 lambda, plus 6 into 2 plus 6 lambda, 90. And you solve for lambda basically.
Yeah.
Minus 6 plus lambda, 150, 100, 100, 6 3s are 6 2s are 12, 6 6 are 36, lambda is equal to 19. So that is equal to how much? 160, 156, correct? 156 plus 137 lambda. Wow.
113 lambda.
How?
So because it's 100 lambda.
100 lambda plus lambda.
Plus 12 lambda.
6 6 are 36.
Oh.
Yeah. You know, all that is going to happen when you do the paper now.
Yeah.
You know, because you're focusing on the concept now, so you're
Yeah,
not
not the
there.
math.
Not the math. That's the reason for that. Is equal to this is minus 137.
Yeah.
Right? So lambda is equal to minus 1. After that, you know, you'll get a nice small value, you'll feel, oh god, for this we did this. But it's quite reassuring कि your answer is right.
Right, yeah.
Now what do you do?
Now
you want to find a distance. So that will give me the coordinates of m.
Okay.
So you put this back. You go on putting a lot of things into it. Substitute this in n.
In m, okay.
So that will give you the coordinates of m. So m is minus 7, 5, correct?
Mm-hmm.
And minus 4. Correct? Now P, now you can use distance formula, or you find a vector and you find a magnitude.
Okay.
So since we are doing vectors, we'll find vectors. So
minus 1.
yeah, PM or OP, NP does not matter. M minus P. So that's minus 1, minus 10, minus 6. So the magnitude of this is the distance. Root of 1 plus 100 plus 36. So root of 137 is the shortest distance between the point. Quite intense. A lot of things happen.
Yeah.
We have to find a minimum distance between a point and a plane. Now they've given you the equation of a plane in vector form. So it's always better to get the Cartesian form. So what you do is this is your point. This is a direction vector d1, d2. You take the cross product. When you take the cross product, you will get the normal vector. Correct? Once you get the normal vector, that normal vector becomes the direction of the line. We know point P, find the equation of the line. Correct? Once we get the equation of a line, it helps us to assume the coordinates of m in terms of parameter. Correct? Then you find a Cartesian equation of the plane. R dot n is equal to A dot n. That's your Cartesian equation of a plane. Then you substitute this point in the plane. You substitute the point in the plane to get the value of lambda.
And then you plug lambda
And put lambda back in m to get the coordinates of m. So now you know your P, you know your coordinate of m. That's a foot of the perpendicular. You find a distance formula, or you find a vector Pm and find a magnitude. Correct? So a lot of skills are involved in this.
Yeah, in one question.
Okay, now next.
Find the distance between.
Now how do you find the distance between two parallel planes?
How so?
The answer is not 12. So you can't look at the constants and work it out. Therefore I said. So you have one plane. You have another plane. Pi 1 and pi 2. Those planes are parallel. Find the distance between them. Now what distance are they referring to? The shortest distance.
Okay.
The perpendicular distance. Means it has to be perpendicular to both.
Okay.
How do you do this?
You find both the points, that's for sure. So you find one point on pi.
Yeah, but what do you find? Those points which are exactly perpendicular.
How do you know those points?
You're following? You can't take a 1 point here, 1 point here and 1 point here. Now that won't be a perpendicular distance.
That only the straight.
So you have to ensure that you have a corresponding point. And that distance, you can take any point, you can take this also, but it should be corresponding.
Correct.
Now that's the key idea.
How do you do that?
Think, how do you, what is the normal vector be? What is this normal? This is normal.
Yeah.
What is the normal be?
0 na?
Normal, array, from the Cartesian, how do you get the normal vector?
So it's just 3 minus 1 2.
3 minus 1 2. So that's your normal vector. So the normal vector which is same for both.
Yeah.
It has to be same for both because the planes are parallel.
Correct.
Now can you assume any point A on pi 1?
Okay.
How do you
Yeah,
assume?
X, Y, Z.
But can you assume a specific value?
No. Oh, you can, but
You can. So suppose if I take my x as 0,
Okay.
then minus y plus 2z is equal to 10.
Yeah.
Correct? Now suppose if I take my y as 1.
Then you just put 1. So 3x minus plus
So
2z
what is
equal to
it?
10.
Minus 1 plus 2z. Very bad. So let's take 2. Correct? And you know why?
Why so?
Avoid fractions.
Oh, yeah, makes sense.
6. So z is equal to 6. So that means this point A is 0, 2, 6. I just assumed any random point.
Yeah.
But the problem is now I can take any random point. Now I have to take the B correspondingly below.
So you take your same x, y, z points for B as well.
But I have to get it now. How do I ensure that? So suppose if I call my B coordinates as A, B, C. What does this mean? Or else can I find an equation of AB?
Of AB?
Huh?
Yeah, you can. No? So because you have a normal, you
Equation.
have a point A.
Correct.
So it'll just be
So
A
your
plus
normal
A.
vector will become the direction vector.
Yeah, A plus lambda B basically.
Correct. So R is equal to A plus lambda B. So A plus lambda times the direction vector. So that would be easier. So that means my x is equal to 3 lambda parametric form. Y is equal to 2 minus lambda. Correct. And z is equal to what? 6 plus 2 lambda. So what is this? This is any point on the line.
Okay.
Now
So
I want the one corresponds to B.
Correct.
So I assume B to be this. And this B will lie on the other plane.
Yeah.
So 3 times 3x is my other plane. So 3
and
times.
you just put in place of x.
It's basically what are you doing? You know, basically
the same.
you're the same as we did earlier. We assume a point 1. And so basically you're finding the distance between the point A and this plane.
Got it.
You can ignore the plane then, you know, once you get any point.
Understood.
Just take randomly any point. Minus 2
So you took
minus.
any 3 random numbers for x, y, and z.
Yeah, x and y I took any value.
Okay.
And corresponding I found a z value. Just try to avoid fractions. Otherwise you'll go to hell. Anyway, by 2 years IB you've done enough. So you don't want more hell. Plus lambda. 6 2s are 12 plus 4 lambda is equal to minus 2. So 9, 10, 14. And this is how much? 10.
Minus 8. Oh, sorry, positive 8.
No, plus 10. Minus 12.
So minus 2 plus 12 is 10. And half that minus 12.
So minus 6 by 7.
Yeah.
That's your lambda. God, this becomes dirty little, but we can't help it. Now what do you do? So what's your coordinates of B? Put this lambda in this.
Okay.
Right. So that's minus 6 3s are 18 by 7. Huh? Comma 2 plus 6 by 7. 7 2s are 14, 20 by 7. Comma. Now put 6 by 7. 6 minus 12 by 7. 42, 30. 30 by 7. And then you find your vector AB and the magnitude basically. Find the vector AB and find the magnitude of AB. That will give you the answer. You know the fractions are coming in. You can use a calculator now. This may come with calculator.
Because fractions.
Yeah.